So there's two equations for delta G. These are the two equations. Let me show you. You want me to show you an example of how you use them? Is that helpful? Okay. So if I wanted, for that problem I just did, if I wanted delta G, then I would say, well, negative delta G standard minus R, 8.3145 joules per mole Kelvin, times T. What temperature will I use right now if not specified? Yeah, 298, which is 25 degrees C. If not specified, that's your go-to temperature. Times the natural log of K. K was 3 times 10 to the minus 10 for the previous problem. This would give me delta G standard. Okay? So now this is at equilibrium. Okay? So this is at equilibrium, and notice I put KEQ in here, or RK from the previous problem. So that forces equilibrium. In the scenario where you're not at equilibrium, then you have to use the second problem. And you have to do the calculation that I just did first. And this number is going to go in here. Okay? And usually then we would ask you, well, what's delta G at specific conditions? So let's say I want to know delta G, and let me give you a couple conditions. For the previous problem, let's say A minus was 1 molar. And let's say HA is 1 molar. And let's say H3O plus is 2 molar. Okay? Just making up a couple numbers for us. And I want delta G. So how would you do that? Well, first write out the reaction. So my K, this K right here that I wrote down earlier, that K goes with the following reaction. HA, because this is a Ka, I'm writing the general reaction for an acid now. The acid loses the proton, water gains the proton. So that's my general reaction for an acid. That goes with my Ka from the previous problem. Okay. So if you're okay with that, to do this problem, I need to write Q. Q, H3O plus, A minus, over HA. I don't include water. It's really 1 because it's a liquid. Okay? So, and remember, these are all initials for whatever state I'm starting at. So, Q in my case is 2 molar times 1 molar over 1 molar, or 2. So I just plug these numbers in, straight up into there, and now I can find delta G. Delta G is delta G standard plus, by the way, where did I get delta G? From what I just found. This number up here is what delta G standard is. Okay? Whatever this calculation turns out to be. Plus R, 8.3145. Why am I using this R? The units of joules. Yeah. T, 298, times the natural log of Q, 2. This calculation will give me delta G. So delta G standard is at specific conditions where we're at equilibrium. However, delta G here, without the standard, the superscript 0, is a non-equilibrium value. And so I need to use this to calculate whatever it is. Okay? So that's a pretty typical delta G sort of problem. Either sometimes you'll see in question just this, and sometimes if we give you the concentrations, it's this kind of problem, where you have to do what's in black first in order to do this part because you need the delta G standard. Okay? That's a pretty typical problem. All right. Any questions before I move on? the overview of this one. There's a couple ways that you can use this problem. And by the way, the standards can be there or not there. So this could be for delta G standard, or if you remove all the standards, superscript zeros, it could be just for delta G. Depends what you have. Okay, for this kind of problem, remember you also have this, RT, ln, K. So this could go a couple different ways. One way this could go is I'm given information about, let's say, delta H and delta S, and I want K. So use this combo sets of formulas to do that. So you're basically setting the right-hand sides equal to each other. Another set of problems, especially with this top equation up here, is the formation value. That's product where you go products minus reactants are the values. So we could give you the formation values for delta G, and you go products minus reactants to get delta G. We do that for delta H, and we can do that for delta S, though they're not called formation values in that case. You just do products minus reactants. The problem I did in the last class is exactly this. So if you're asked to find delta G standard, there's actually a few ways to do it. There's three that I can think of off the top of my head. One is if you have K to use that equation. It's one way to find delta G. Second way is if we give you formation values of delta G. Third way, if we give you formation values of delta H and the molar values of S, where you go products minus reactants, and you use this formula at the top. Those are really the three ways that come to my mind. The normal ways to find delta G. Standard, okay? Does that all kind of make sense? It's just an overview.
So the first one, if you were K and not a temperature,
if I'm given K and not a temperature, we would assume it's 298 unless otherwise stated. And in fact, for almost every problem we've done so far since chapter 15, we have been at 25. So all the Ka values and Kb values tabulated are at 25. So you might not have known that, but we've always been at 25. It's just now we're telling you because there's a T in the equation. We didn't tell you that before because we kind of didn't care, and there was no T in the equation. Yes?
How can you tell when you're looking for when you're asked to find delta G naught versus delta G when it's not at normal? I was getting.
How do you know if you're asked for delta G naught or delta G?
Yeah.
We have to specify if there's a zero here or not. That's the only reason. Yeah. Or the word standard. Yeah. That's it.